Hello everybody. Today we're going to talk about solving inequalities with variables on each side. And once again, this is pretty much a review of solving equations with variables on each side. But you just have to remember to graph your answer, and anytime you multiply or divide by a negative number, got to make sure you flip your inequality sign. So what we'll do is we'll do the same exact problem two different ways. Now before we start, it's so important that, and I'm just going to shorthand this because we'll talk about it more in detail in the next lesson, but remember to always distribute first if you have parentheses, right? And the second thing you want to do is combine like terms on each side. That's where you add up the like terms and keep them on the side they're on. And then the third step would be get variable terms on the same side. That way you can combine them. Okay, so we're going to focus on step 3 for this lesson. Steps 1 and 2 won't really be present for the most part, but you always want to check for those first. So here's the same problem written twice because we're going to do the same problem two different ways. So remember, anytime you're solving an inequality, the first thing you want to look to do is distribute if you have parentheses. We don't have any parentheses, so I'm going to solve the one on the left-hand side for right now. But then we look for like terms. Well, there's no like terms on each side, right? These aren't like and these aren't like. So now our third step is to get our variable terms on the same side. So I'm going to start with this positive 5x. If I subtract 5x, that'll cancel off on the right. And now I'll put it on the left-hand side and be able to combine these. So 7x minus 5x would be 2x. Rewrite the rest of your problem and what's left. I didn't have to write the positive 8 there because it's a plus 8. It's the first term on the right-hand side there. And now it's simply a two-step inequality. Add 6. So we have 2x is greater than or equal to 14. Last step is to divide by 2. X is greater than or equal to 7. So for our graph, I'll just put 7 in the middle. Put two numbers bigger and two numbers smaller. But we do a closed circle on 7. And since x is greater than it, shade to the right. Now let's do that problem a little bit differently though. So remember, there's no parentheses or like terms. But let's say I wanted to subtract 7x here. I could do that. This is totally allowed. And this is definitely going to work. But there's a little bit more things you have to be careful of. I would say that most people, when they're solving inequalities, prefer their variable on the left. Additionally, we're making it negative. So the 7s will cancel off, 7x's. We're left with negative 6 is greater than or equal to, this will actually be a negative 2x on the right-hand side, plus 8, right? So the variable terms on the right, compared to the first example where the variable term was on the left of the inequality sign. So now we got to isolate this negative 2x, so we're going to subtract 8 from both sides. So negative 6 minus 8, that's going to be negative 14, greater than or equal to negative 2x. The last step is to divide by negative 2. And we got to do our math from left to right. So we get positive 7 here. The sign's going to flip because we divided by negative 2x. I do recommend that students rewrite this to help them graph it. X is greater than or equal to 7. But notice we got the same exact answer as last time. So you could kind of judge which one was easier. In my opinion, I think this one was way easier. Why? Because we made the variable term positive, and we didn't have to divide by a negative number, so we didn't have to worry about flipping the sign. But it really doesn't matter which variable term you move, as long as you do your math work right. Remember that if you multiply or divide by a negative number, you got to flip your sign. And then if your variable's on the right, I do recommend you rewrite it to the variables on the left. If you remember those key things, you're going to get the same answer. Okay? So usually there's two different ways to, not usually, there's always two different ways to do the problem when you have variables on each side. All right? Okay, so even though we're only in the second actual problem, I want you to try this one on your own. So at this point, pause the video and try this question on your own. So the next 15 seconds will be blank. Okay, so hopefully you try that on your own. This is a great way to learn to see if you're on the right track. So again, you might have done it a little bit differently, but you still should have the same final answer. So I'm going to add 2x to both sides. Why? Because I'm keeping that variable term positive, okay? You might have done it a little bit differently, but I have positive 5 here. I don't have to write that plus because it's the first number on that side. And we get 7x minus 9. Now we got to isolate the 7x. So we'll add 9 to both sides. These cancel here. We get 14 is greater than 7x. Divide by 7. Since we're dividing by positive 7, we don't have to worry about flipping the sign. So that's our answer. I do recommend, though, you rewrite it. I'm going to rewrite it over here. So x is less than 2. Put the variable on the left, right? These two mean the exact same thing. And now we're just going to graph it. So we have a open circle on the 2 and shade to the left because we want numbers less than 2. All right. Now again, if you subtracted 5x from both sides, you still would have got the same exact final answer of x is less than positive 2 as long as you do all your math work right. Okay. You will have to actually flip the inequality sign during your solving process, but you still will get a final answer of x is less than 2. So let's do one more, and we'll kind of incorporate what we're going to do the next day, which is multi-step inequalities, meaning anything goes. Okay, so here's our last example for today. 3x minus 10x plus 7 is less than or equal to negative x plus 4. So we actually do have an additional step we have to worry about. There's no parentheses, but we do have like terms on the left-hand side. If I'm going too fast, remember, just go back or pause the video, allow yourself to catch up. But these two are like 3x minus 10x, or 3x plus a negative 10x will be negative 7x. So rewrite your problem. And now at this point, it's just like the other two problems we went over today. So we want to get our variable terms on the same side so we can combine them. I'm going to choose to make the variable positive. And by the way, if you have two terms, the way you would make the variable positive by getting them on the same side is if you move the smaller one by doing the inverse. So actually, if I have negative 7x and negative x, the smaller one is negative 7x. So I'm going to do the inverse and actually add 7x to both sides. Now, you don't have to do it that way. You could have done it differently as long as you do the inverse operation. So we get 7 is less than or equal to, and a negative 1, I just want to rewrite that so it's a little neater. Negative 1x plus 7x is 6x. Okay? Now we got to get the 6x by itself. We subtract 4 from both sides. 7 minus 4 is 3, so 3 is less than or equal to 6x. And if you guys notice, I try to do one problem involving a non-integer answer, and this one's going to be the case. Hopefully, you're not looking at that and saying the answer is x equals 2, because we actually divide both sides by 6, right? So 6 cannot go into 3, so we got to reduce that. And 3 divided by 6 reduces to 1/2, right? Because 3 goes into both of those. So I'm writing the answer over here. We don't have to flip the sign because we divided by a positive 6, right? And again, I'll continue my work right over here. Let me just make a red arrow so you can follow that. So 3 over 6 is 1/2. Sign stays the same, right? X, and now I do recommend you rewrite that. X is greater than or equal to 1/2. Okay? So how do you graph that? Well, you do have to know where that is a decimal, even though we like the exact answers. As a decimal, that's 0.5, so even as a decimal, it's exact as well. But 0.5 is between 0 and 1. So for your graph, I'll do it up here. Make at least 5 numbers on your number line. But it goes right in the middle of 0 and 1 because it's 1/2. It'll be a closed circle. And since x is greater than or equal to 1/2, we're going to shade to the right. So that means anything including and bigger than 1/2 is an answer to this inequality. So there's to finish a problem with variables on each side. It's a multi-step inequality, and what we'll build on the next day. So hopefully you found this video lesson helpful. Again, it's just like, excuse me, just like solving equations with variables on each side. Just have to be careful with your inequality sign, flipping it when you need to if you multiply or divide by a negative, and then graphing your solution set on a number line. So hopefully you found this video lesson helpful. If you have any questions, please let me know. Have a fantastic day, everybody.